Hello everyone, it's Jonathan, and I'm recording a quick video to show working with data streams and then also using the QuickDAC microbus hardware in the loop for the real-world UART. And so we're going to play around with that, and I also want to cover some of Montage, which I mentioned briefly in one of the videos, but I haven't really described Montage much, so we'll also get into that. So let's go ahead and create a new project. Get started. So this will be Okay, so what we're going to basically be doing in this real quick is just I want to include my microbus board. And by the way, I've got my microbus board wired up with a loopback, so the RX and TX are connected together so that when I transmit, it comes back and gets received. So that's on slot 3. I need to use this slot expander simple to get to the UART. So that's my transmit. Data comes in and goes off the board, and then receive data comes in and goes out to anything else that wants to connect to that stream. So what we are going to do is add a virtual microcontroller. Virtual micro. And I'm going to wire up a button so that when the button is pushed, I'm going to transmit hello world, I'm going to transmit out, receive it back, and then see it show up back here. That's the first thing I'm going to do. Okay, so let's go ahead and open up the project. Alright, so here's my embedded microcontroller. So first I'm going to add that variable for my button input. And then I'm going to go ahead and add a interrupt service routine for the received data. So this is data received. That's an unsigned char pointer data, specified length. So I'm just going to set a breakpoint here so I can see when that comes in. And all we're going to be doing is waiting for this to go high. Push button, then I'm going to be transmitting this hello world string. I don't have a way to send this yet, so I just need to build this so that Virtuoso is aware of this variable and this function, and then I'll also create my data streams. So we've built it, now Virtuoso is aware about it, and I'm going to go back to my target builder. Target model builder. I'm going to add that variable, so we just start typing button, and that's going to be a Boolean input. And now we want to create these upstreams and downstreams. So upstream is a data stream that's coming from the C microcontroller up to the C# host, and then downstreams are just data streams coming down from the C# host to the microcontroller. So to create an upstream, all I just need to do is name it. So this will be my upstream. And this is going to create a unique handle just based on the name. So we have an API function to call to send data to the stream. We just need to reference that handle. And then for downstreams, we just need to specify which interrupt service routine is going to be used to handle that data. So to do this, I just need to start typing data, and it sees if it's found in the data received callback function. So we have our downstream is going to call this data received interrupt service routine, and my upstream will be the handle for the stream to transmit. And then we have our push button input. So we close that. Now we can see our ports, and we need let's add a push button. Push button. Okay, so my upstream is going to be wired to the transmit, and then we've got this wired to loopback, so it's going to come straight back into data received. So I'm just going to update this. Reload. We will see my push button on the view. So position that, run the application. Okay, the application is running. Oh, I did not add the function call here to actually transmit this. So when we added that port, Virtuoso.h has these simple APIs for writing a buffer to a Virtuoso upstream, and a handle is passed in with a pointer to the data, and this is the upstream handle that was created. So I'm going to call this, and this is my handle. Pass in hello world, and inside hello world. Okay, so this should now work. And again, this would all be in general inside the hardware abstraction layer for virtualizing the UART. So also, this is our slot expander, and we need to turn on the UART properties here, and this is where we can set what baud rate. So I'll go ahead and bump this up to 115.200 baud rate, and we can set a single stop bit. So this is what configures this specific slot's baud rate for the UART. So we want to go ahead and do that so we get the baud rate. It wouldn't really matter because we're just dealing with the data stream, but that's how it will go over the wire. Alright, so now update those. Run our application. Alright, so we're running, and when we push the button, we have hello world. So there it transmitted, and went out the QuickDAC microbus, came right back that quickly. So pretty cool, very easy, and this is actually giving us UART, so we could wire this up to the oscilloscope and see this data coming off of the transmit pin and going back and forth at the right baud rate. And what I want to do now is use another control to help see that data. So it may be the case that I have to log, try to debug an issue by putting this bus on an oscilloscope and decode the data stream with an oscilloscope. But since it's all floating, the data is floating around in the host, we can add other components to visualize it, work with it, and stimulate our data receivers with data. So we don't have a console control. This is what I want. I want to be able to drag and drop a console control that we can just type into, but we have not downloaded that. So for that, the Virtuoso ecosystem uses Montage. So I'm going to close this. So this is the Montage launcher, and the Montage launcher is the local client that you use to download new packages. So I've actually already run this, so it's running inside the tray. So just a quick overview. When this ecosystem, the Virtuoso ecosystem, is selected, this is what tells Montage which ecosystem is going to be handling packages when they're downloaded. And so you select Virtuoso, and now when you're downloading packages, it's actually forwarding those packages to Virtuoso. And these are the bootstrap packages that you use to actually set up Virtuoso. So if you install this Visual Studio 2019 Embedded Target Development Toolkit, you just simply install it. I've already got it installed, so it shows launch. But if you just install it right here, this installs everything that's needed in one single click of the button. It installs the host plugins, it installs the core framework, and everything. So anyway, I've got Embedded typed in because I was downloading other packages, the Embedded QuickDAC microbus components. So you can see here, this is the port definition library for the microbus. This is the microbus board itself, this package, and then these are the individual clipboards. So as new components are available for the clipboards, you can just go out and download them, and they'll give you the direct functionality of that clipboard. But I want a console, so I'm going to just type console, and now I can see this is the Virtuoso WPF C# console terminal. And so I just need to download it. Okay, so now I have it, and I can go back and rerun Virtuoso. open my project. And now I can see my console terminal. So this console terminal could have been developed by absolutely anyone. Anyone who knows how to develop a C# component can develop this and create a Montage package and push it up to the ecosystem. Even sell it if they want to sell it and make money. But most of them will be free, so you can just go online. But again, infinite scalability of this platform, so anyone can design and create useful components to extend the community. So I'll go ahead and drag and drop this console terminal. So the console terminal has 2 input streams and 2 output streams, and we can configure whether we want data that comes in to be forwarded to the outputs, which I do. I'm going to forward in stream 1 to out stream 1, and when this includes a console view, a console terminal on the view. So if you type into that terminal, you can also select whether the manually typed in data is sent out to the stream 1 and stream 2. So those are checked, and that's going to show up. So we have data displayed coming in is going to be displayed with white. Data coming in on stream 2 is going to be white, and then we're going to be forwarding data in stream 1 to out stream 1. So what this will let me do is actually see the data between the path from the microcontroller that's going to come in here, and then it's going to get displayed on the console and then route to the microbus. It's going to loop back and then come back to the microcontroller. But we'll be able to actually see it on the display. We can see it live. We don't have to set breakpoints. We don't have to use an oscilloscope. So let's push that and open Visual Studio. Okay, so I don't have a breakpoint. Just need to move that console terminal. Let's get this guy down here. And run. Okay, so now when we click the button, you can see it's picking up all the hello worlds, and we can actually see it coming in live. So this push button right now does not have an interrupt output. It only has a Boolean output for the state and not the event. And this is just an older version of the push button, but we would generally want to just wire that up to the interrupt, so that we wire this interrupt into our interrupt in the microcontroller. So anyway, so this is showing the console control that we went and downloaded from Montage to visualize it, and we could also manually type in data. So if I set a breakpoint here and I manually type H, capital H, then we can see that data comes in. So very useful for debugging, and again, this would let us directly interface to some other system over UART. We could use the microbus board. We could also, in the case of UART, if we're wanting RS-232, we could actually use a serial port control directly. So this control, you can select the COM port, and you're actually using the COM port of the computer directly to send and receive data. Anyway, that's it. I hope you enjoyed the video. Thanks.